Well, last night on the first episode of the Great British Bake Off's latest season, we had a twister-rooney, as Noel Fielding put it, when the 12 new bakers were faced with a technical challenge involving one of these fondant fancies. Many of them went for the ground almonds, when what they needed was the almond essence, because they had no recipe. They had to rely on their fundamental understanding of the principles of baking, as well as their taste buds. Now, this reminds me of what I'm seeing when I watch people trying to get to grips with tools like ChatGPT or Claude, our generative AI large language models. And this prompted me to produce a small extra portion of Rose's AI to recognise the challenge that we saw in the Bake Off tent and look at how this can tell us something important about how we can better understand our tools like ChatGPT and Claude. Welcome to Rose's AI. I'm Professor Rose Luckin, Professor of Artificial Intelligence, and Rose's AI is all about helping you to understand AI through understanding the basic principles, and a bit of occasional baking happens too. So let's get back to that technical challenge that we saw in the first episode of the Great British Bake Off. So our 12 new bakers were presented with a fondant fancy, an array of ingredients. And they had 5 minutes to explore the fondant fancy, and then they were told they needed to produce 9 perfect examples of this using whichever of the ingredients they thought right, in whatever proportion, according to whatever method. There was no recipe. Now, a lot of the times when we're using our modern generative AI tools, I see people wanting to follow a recipe, and that's understandable. It's how you learn to bake a lot of the time, isn't it? You have a recipe, you follow it, you get a nice result. So all too often we see 10 top tips for the best prompts you can use with ChatGPT. These are recipes, and they are useful, but you will be much better equipped to use these tools powerfully if you understand the principles. So let's unpack that a bit more, because I'm going to explain 3 core principles to you as I talk through the Fondant Fancy Challenge. I'm going to talk to you about the importance of understanding structure. I'm going to talk to you about the importance of recognising that appearance isn't the whole story. And I'm going to talk to you about context. So they're the 3 principles that we're going to cover today. Now, in the previous episode of Rose's AI, I also gave you 3 things to focus on. I talked about data, processing power, and algorithms. So let's think about structure. So when the 12 bakers were faced with the fondant fancy, they had 5 minutes to look at it. Most of them cut it. We see, as Alison Hammond had told them, light sponge. But it needs to be firm enough to support the buttercream on the top and the fondant icing. And these are not perfect examples of what the Bake Off tent had, because they also had raspberry jam in them. So there are some real structural components here that need to be borne in mind. You couldn't, for example, use something like an Italian meringue, because although it would be sweet and it would be light, it wouldn't support the buttercream and the fondant icing. But equally, reaching for the ground almonds, you have a very dense ingredient. So whilst you might have detected the need for the flavour of almond correctly, the texture is too dense to produce the light sponge that's required for the fondant fancy. What you need is the almond essence that's light. So you need to understand the structure in order to understand how to produce it. Now, with tools like ChatGPT or Claude, our large language models, it's really helpful to understand the structure when you're using them. And as you'll realise from the first episode, I like to talk in 3s. So there are 3 components to the structure of large language models that it's important to remember. First is that they are trained on millions of examples drawn from data. So that data is a core piece of the structure of the large language model. Second, they produce the next sentence in a word based on statistical probability. So we've got the structure of data, we've got statistical probability, and then the third piece of structure that I want you to understand is that what they produce will mirror what they've been trained on. And what you see often is what we call hallucinations, because there isn't anything accurate for the large language model to mirror because it hasn't existed in what they've been trained on, so they make something up. So that's your structure. So first principle, structure is important. Understand the structure, just as understanding the structure of the fondant fancy would guide the bakers to producing the right example. Understanding the structure of a large language model will help you produce a much better answer without needing a recipe. The second is appearance. So when we look at our lovely little fondant fancy, yes, it looks like a soft, sweet treat. And it is a soft, sweet treat. But it requires a balance of flavours, a balance of textures, a balance of components. We need the right balance of sweetness between the buttercream, the jam, the fondant icing and the sponge so that we're not overwhelmed by sugar, but we get the right flavours. We needed the almond in the sponge, in the buttercream, the raspberry in the jam, and a little bit of raspberry in the fondant icing as well. So the appearance kind of denies the complexity of what's involved. Now that's true with our ChatGPT and other tools like Claude or Gemini or Copilot, these large language models. They appear to produce intelligent behaviour, but what they're actually doing is reproducing what the patterns in the data they've been trained on predict they would reproduce. They are reproducing patterns from data. They don't understand anything they produce, so they appear to be intelligent, but what they're actually doing is reproducing patterns that they find in the data. And they're matching those patterns to the patterns in the prompt that you enter. So it's a case of matching input to output. So first principle was structure. Second principle is about appearance. And the third principle is to do with context. So context is everything. Now this was true yesterday with the bake-off as well. So almond, as in ground almonds like these. Now this is exactly what you want when you're making something like marzipan. So if the context had been to make marzipan, going for the ground almonds would have been exactly the right thing to do, because almond essence is liquid. It wouldn't give you that lovely marzipan texture. So the context was fundamental to the decision about what needed to be used when it came to building one of these little fancies. You needed to understand the context and the context that required that light sponge. Now, when it comes to generative AI tools, then we're in exactly the same position. Context really matters. What you are doing when you give a tool like ChatGPT or Claude a prompt is you are giving it the context in which you want it to operate, the context that it will use to go away and do its pattern matching and statistical prediction. So that context is really important. So let's run through those three principles again. Understand the structure. Understand that your generative AI tool is based on being trained on millions of examples of data, using statistics to predict what it's going to say comes next in a sentence, and remembering that the output that it produces will mirror what it's been trained on. So for example, you might have a tool like ChatGPT that's been trained on a lot of medical journals, for example, and then it will be able to give you output about what's in those medical journals. Alternatively, you might have a tool that's been trained on a lot of examples of engineering material, and then the ChatGPT can appear to talk knowledgeably about engineering. So it can appear to know about medicine, it can appear to know about engineering, but it's only because it's matching patterns in the data that it's been trained on. So understanding that structure is really important. The next thing I said was recognizing that appearance isn't the whole story. So our tools, our large language models, can appear to behave intelligently, but we need to remember that what they're actually doing is pattern matching. And finally, context is everything. Just as with our bakers, had they been making marzipan, the ground almonds would have been right, but they weren't. They were making light sponge. In the same with our tools like ChatGPT, The context is really important, and the more information we give these tools about context, the better the results. Now that's why the prompting frameworks are very, very useful, because they help you structure the context that you're giving to the large language model. But you need to understand that what you're doing is building the context. So there are your 3 principles for today. Now if you want to be like Paul Hollywood of AI, then you need to get to grips with the principles. If you take somebody like Paul Hollywood, he's not just a brilliant baker, like those 12 contestants in the tent. He really understands what happens with baking. He knows what gluten in flour does, how it behaves. He knows how temperature impacts on yeast. He can build you anything from any ingredients. He doesn't need a recipe. And that's how you need to become in using your AI tools. Aspire to be the Paul Hollywood of artificial intelligence. So remember, Rose's AI is all about getting to grips with the basic principles of artificial intelligence. Because if you can understand the basic principles, just like when you're cooking, you won't need a recipe. You will build a flexible understanding of artificial intelligence, and that will empower you. I hope you've enjoyed this little extra portion of Rose's AI, brought about by the Twister-Rooney of the first episode of the Great British Bake Off. Next time, I'll be building that lovely Victoria sandwich with you and talking about layers. And talking about layers in the neural networks, which are the powerful computing structures that help us to build our machine learning AI and give us sophisticated AI tools, such as the ones we're using at the moment. Thank you for joining me in my kitchen. I look forward to seeing you next time.